scan rules examples. So with the server header disclosure, you'll see we have this, there's just one method, which is scan, and we've got some parameters. We've got the standard message there, so message dot, you can see all those things. We also have that option there, so that gives us a kind of helper, and the source is actually, so that actually gives you access to the analyzed HTTP, so it is, so HTML. So that's actually decoded for you if you want to play around with that. It's non-trivial. In this case, this one is very simple. So we set up kind of set of variables there, and all we do is we're just checking to see if there's a server header, and if so, we raise an alert, and that's the information that's given. So that's a very simple passive scan rule example. Find emails of a different one. So in this particular case, we've got a regex expression, and we go through and we check the content, so we're ignoring things like images, flash and things like that. So you can be very particular about the things you want to look at. And then we get the response body, convert it into a string, and we're testing the regex. If we find one of those regexes, we actually build up a list of all of the emails rather than raising alerts, and then we raise an alert. So this PS option actually parameter allows you to raise the alerts there. And with the active rules, we don't have as many active rules, but we do have a fun one, which was added recently. And this is the user-defined attacks. One thing we've been asked quite a few times is, with the active scanning, how do I add my own payloads? And the answer's always been, well, what do you mean by adding your own payloads? How do you know what they actually do? Because what the Zap doesn't just throw a load of bad stuff and then just kind of guess what happens. What we try to do is we try and do detection more intelligently. So with something like XSS, we try and see where a parameter is reflected in the output, and then we try and see the HTML context in which it's reflected, and then we try and inject the relevant characters to escape out of that context so that we can be fairly sure that you can actually run JavaScript. So it's not a question of just, oh, script alert is reflected, therefore it's vulnerable. That might be safely escaped. In SQL injection, there's loads and loads of particular timing attacks and things like that. So detecting things with active rules is non-trivial. But in this particular case, we've got a very simple example. We have a load of attacks, so you can just put in whatever attacks you want. And then we have a load of things called evidence. So this is basically, well, there's strings, but regex patterns. You can change those. And all we do is, what you'll see is, active rules get called twice. Once for scanning the node, so a node is, it's like a URL. It's within the sites tree, a separate node. It's a combination of the URL and the unique parameters. So if your URL gets called with a different number of parameters, not the different values, but different number of parameters, then you have separate nodes in the tree. So as Zap works down the tree, scanning a subtree, every time a node is encountered, that will get called first. We're not too bothered about that. What we want to do is attack the parameters, so you get called with this function. In this particular case, we work out how many attacks. If you're doing your own local scripts, you don't have to worry about this, but if you want to publish these, put them in the scripts repo, we have some conventions. So if the attack strength is low, we should only make like a half a dozen attacks per parameter per page. Medium is about a dozen, high is 24, insane is as many as you like. There are some rules that will do hundreds of attacks. So basically, in this particular case, we loop through the attacks. If we exceeded the maximum number of attacks, we return. You can disable that locally, of course. Then we clone the request, because we don't actually want to change the request that's happened. We want to create a new request to change it. Then we've got this option to set parameter, and this shows how the script rules don't have to worry about what they're attacking. The set parameter works it all out from the script input vectors that support is enabled. You then make a send and receive. In this particular case, we're not following redirects, we're not handling anti-CSRF tokens. And this is where in this particular case, we're checking to see if the result code is in the 500 range, in which case response code is in the 500 range, then we raise an alert. But you can do anything you like here. And in this particular case, we check against all the above regexes, and if one of those is found, we raise an alert, and we actually the text that's found as evidence, and that will then be highlighted. So that is an example of an active scan, and we also got the good old files light, which shows you can do lots of other things. So there's some quite complex things you can do. I mean, you can do pretty much anything you like. That's why it gets interesting. It's how do you actually detect vulnerabilities. That's one some people don't understand is detecting a particular vulnerability in a particular application. If you know it's there, it's easy to code. Trying to detect a generic type of vulnerability against any sort of application is quite hard. So, but this is where scripts are actually really useful. If you know that you have particular types of applications and there are particular types of vulnerabilities that are quite common, you can write a script rule which targets just those. And it could target the frameworks your developer is using or particular patterns that you know occur. So it can be very specific rather than the generic ones that we actually have to cope with.